Welcome to Chapter 13. First section is 13.1, Simplifying Radicals. Go ahead and make sure to fill in your date up here so you know when you're working on it. We'll start with a box here to kind of give you some steps. First thing is you want to make a factor tree. In a factor tree, our goal is to find prime numbers. And just a little refresher, factors are things that multiply together to get to a number. Okay, so you're going to find pairs, and the pairs are prime numbers at the bottom of the tree. Step 3 is you're going to take out the pairs once. And then the leftovers go under the root. And then simplify if you can. Okay, I'll start with a bunch of examples here for you. I'm going to factor 108. So I know that two numbers that multiply to 108 are 2 and 54. 2 is a prime number, so I'm going to circle that. Two numbers that multiply to 54 are 6 and 9. Keep factoring here. This is 2 times 3, and this is 3 times 3. I'm going to circle all my factors. All right. I'm going to take out my pairs. So I have a pair of 2's. That's going to come out once. Multiplied by my pair of 3's. That's going to come out once. My leftover 3 is going to go under a square root. Simplifying that, 2 times 3 is 6. Square root of 3. Fix that. 3. Alright. So that's simplified version of 108. So it's a simplifying radical, so we're going to see our square roots in there, possibly, unless it's a perfect square number, which our first example here, 49, if I break it down into 7 times 7, those are both prime numbers. That comes out once, so my answer is 7. The other thing that you could recognize is 49 is a perfect square number, so that simplified is 7. Same thing with 64 here. We know that that's a perfect square number, so our square root of 64 is 8. Show you that with a factor tree. So this is 8 times 8, 4 times 2, 2 times 2, 4 times 2, 2 times 2. Circle all my 2's. So I've got one pair of 2's, another pair of 2's, and that last pair of 2's. So 2 times 2 times 2 is 8. Working to simplify 12 here. So again, I'm going to look for some factors here. I know that that's 2 times 6. And factor 6 again, 2 times 3. Circle my prime numbers. I've got a pair of 2's. That square root, that's the 3, that's my leftover. Okay, more examples here. Break down 32. So let's do 32 is 8 times 4. Again, you could start any way you can multiply to 32. 8 breaks into 4 times 2. You can keep going with the 4. That's 2 times 2. Finishing this one, 2 times 2. Circle all my prime numbers here. So this is a pair of 2's comes out once, a pair of 2's comes out again, and then this leftover 2 goes under the square root. Simplifying this, 2 times 2 is 4. Square root of 2 is my final answer. Alright, moving on to the next example here. 75. I know that that's 3 times 25. Factoring 25, that's 5 times 5. Got some prime numbers here. So my pairs come out once. And then this leftover 3 goes under the square root. Final answer, 5 square root of 3. Alright, looking at this next example, our first step is going to be to multiply these two numbers together, because as you guys see, 3 and 6, I'm not going to break those down yet. So I'm going to take this, and 3 times 6 is 18. Now I'm going to build my factor tree. So 18 is, I'm going to do 2 times 9, and then I'm going to do 3 times 3. Finishing this off, taking my pairs out once, and my leftover goes underneath the square root. So my final answer here is 3 times the square root of 2. Alright, so really the big key here is finding those factors and getting all the way down to those prime numbers and then simplifying everything at the end. Next page here, a couple more examples here. 5 times 15, I'm going to multiply that first, so I get the square root of 75. We actually just broke that down on the other page, so I'm going to show you something a little different here. I know that 75 is the square root of 25 times the square root of 3. So sort of like we did here, 5 times 15. I'm going to change this into square root of 25 times 3. I know that 25 is a perfect square number, so I know that the square root of 25 is 5. This root 3 just comes along. So again, that's the same one that we just did on the other page, just a different way to do it there. Letter H here, first thing I'm going to do is multiply that down, 21. I know that that factors into 7 times 3, so those are both singletons, so I'm going to put those underneath the square root. So, oops, not a 2, a 3. So 7 times 3 is the square root of 21. So there was really nothing to simplify after you got to that point right there. Okay, looking at some of these fractions here, I see, I see 2 perfect square numbers. So I'm going to take the square root of 9, which is 3, and I'm going to take the square root of 25, which is 5. That's going to be your final answer. If you wanted to do this separately, you could break that down. So there's my pair of 3's, so that becomes 3. Square root of 25, that gives me my pair of 5's, so that gives me my 5. So that's kind of where those numbers come from. Again, because they were perfect square numbers, we can do that. Alright, the last section here today is what we're going to call rationalizing the denominator. So we're going to get that when we're working with square roots. You actually cannot have a square root in the denominator for your answer here. So what we're going to do is we're going to multiply each one of this, the numerator and the denominator, both by the square root of 2. Because we know that the square root of 2 times the square root of 2 is the square root of 4, which is actually a perfect square number. So I can take that square root. So this simplifies into 12 over, not 4, square root of 4, which is 2. Now I have to look at breaking down 12. That's 3 times 4, 2 times 2. So here's my pairs. That comes out once. So this simplifies, 12 simplifies, which we've done earlier, into 2 times the square root of 3 over 2, which then I can simplify again. 2 over 2 is 1. So my final answer here is the square root of 3. Alright, so that's called rationalizing the denominator. So again, the big key here is that when we multiplied that square root of 2 times the square root of 2, we get a perfect square number, which we can take the square root of. So the square root of 4 is 2. So it's really whatever's underneath that radical is your denominator. So for the second one, we're going to take it, we're going to multiply by the square root of 5 times the square root of 5. We're rationalizing that denominator. So on the top, I get the square root of 35, and on the bottom, again, remember, square root of 5 times the square root of 5 is just 5. 35 breaks down into 2 prime numbers, so I'm actually going to leave it just like that. I'll show you what I mean. So 35 is 5 times 7. Those are both prime numbers, so they would be multiplied together and stay under that square root then. Alright, last one here. Rationalizing this last one. So again, I'm going to take that square root of 14 on the bottom, and I'm going to do the square root of 14 on the top. Alright, I'll fix that square root of 14. So on the bottom I get 4 times the square root of 14, and then on the bottom I just get 14. I can't simplify 14 anymore because, as you see, 14 is 2 times 7. So those are both prime numbers, so it would come back underneath the square root. But I can reduce my fraction here. So 2 goes into 4 2 times. Square root of 14 stays there. And on the bottom, 2 goes into 14 7 times. So your best answer is 2 square root of 14 over 7. All right, that's your notes for simplifying radicals. Your homework is listed right here. Worksheet practice 13.1.